Emma, and I like ham radio. Today we're going to learn about how to use math and electricity.
We've now learned all the ingredients that are used in two very important equations about electricity. Do you remember what our last 4 videos were about?
Let's see, voltage, current, power, and resistance.
Right. In our last video about resistance, what was that unit that we used for resistance again?
Ohms.
Well, ohm is named after a man named Georg Ohm. He discovered a relationship between voltage, current, and resistance, and he created a math formula to describe it.
Ohm's law.
Yeah, the formula he discovered now has his name on it. Now, I know that the words math and formula can make some people nervous.
Not me, I like math.
I know you do, but some people have a hard time with math. But just know that the math needed for the technician's test is very simple, and you're allowed to bring a basic calculator to the test. You just need to know how to multiply and divide. You can do that, right?
Yeah.
Okay, before we dive into Ohm's law, we have to hand out some letters.
Letters?
Yeah. In formulas, we usually use a letter or symbol to represent a concept, like voltage. This is different than the unit of measure. So let's do voltage first. What's the symbol for volts?
V.
Right, and sometimes you might see a V in formulas, but we're going to use a different letter. Do you remember the big long name for voltage that we talked about in episode 3?
Electromotive force.
Good job. When representing voltage in the formula, we're going to use an E for electromotive force. Current is next. The symbol for the unit of current is amps, and we abbreviate that A, but when we used it in the formula, the French got to pick the letter.
C'est chouette.
Très bien. In French, it was called intensité du courant, or the intensity of the current. We use the letter I to represent current.
I always remember imps.
Like amperage or amperage? Whatever works for you. Resistance is a lot easier to remember. It's just R. And so is power. It's just P. So let's go over them once more. Voltage is
E.
Current is
I.
Resistance is
R.
And power is
P.
Okay, I think we're ready for Ohm's law. When you take your technician's test, I would recommend that you immediately write this down on a scrap piece of paper when the test starts, so that you don't have to keep it in your head while you're doing the rest of the test.
That's what I did.
I know. I remember watching you write it down from afar. I have to admit that was a proud dad moment. So here's what you should draw. First, draw a circle, then divide it in half with a horizontal line. Next, draw a vertical line to divide the bottom half in half. Finally, write the letter E in the top half, the letter I in the left side, and the letter R in the right side.
E over IR.
Right. Now, that can be a little hard to remember, but I have an easy way to remember it. Go ahead, Emma.
Eagle over the Indian by the river.
Yep. Eagle, E for eagle, I for Indian, and R for river. So now that we have it ready to use, how do we use this little diagram?
Just use your finger to cover up the thing you want to find.
Right. There are several questions on the technician's test that are just variations on the same problem, just with different numbers. In this episode, we're going to combine our hands-on segment and our quiz time segment and show you how to do a few of those. But first, let's talk about pi.
I love pie.
Me too. If you were watching carefully, you might have noticed that I talked about 4 electrical concepts, but we only used 3 of them. Which one did I leave out?
Power.
Right. There's another formula that uses P for power, and you can remember it if you just remember the word pi.
P over IE.
Exactly. Just draw another shape like we did a moment ago, but this time put P in the top half, I in the left side, and E in the right side. Now that we've got Ohm's pi, let's put it to use.
Let's get hands-on quiz time? Okay.
Okay. Now, remember what I said? The first thing we want to do when we're working some of these problems is to write down the diagram.
Okay.
Okay?
So, no, I'm following the instructions.
Yeah.
I'm going to write a big...
Let's do Ohm's law first.
Okay, so I'm going to write a big circle like that.
Yep.
And then we divide it like that.
Yep.
And then we go like that.
And remember the way the letters go?
Oh, yeah, that's right.
Eagle.
E over the Indian
Mhm.
by the river. There.
Right. And let's also do pi as well.
Okay,
Let's do that on the other side.
so we'll do a nice big circle over here. Doesn't have to be perfect. Oh, crossed. Down. And what's it for this one?
Pi, right? P over IE.
P over I E.
Okay.
There.
What formula is used to calculate the current in a circuit? A. Current equals voltage multiplied by resistance. B. Current equals voltage divided by resistance. C. Current equals voltage added to resistance. Or D. Current equals voltage minus resistance. So the diagram we want to use obviously is Ohm's law, right?
Mhm.
And we want to figure out, so we're looking for current, right?
Okay.
Do you remember what current is?
Let's see. Is it? Oh, I remember amps.
Yeah, yep. So that would be the I. So that means
So
we need to know that.
that.
We're looking for what current is. Current equals. And so one of the things we got to remember is that when one is on top of the letters, that we're going to divide. And if they're
Oh.
next to each other, we're going to multiply. So we're never adding or subtracting. So we can get rid of C and D,
Okay.
right? So which one do you think it is?
Let's see. Would it be divided by?
Right. That's
So
letter B.
A? Oh.
Letter B.
Uh-huh.
Current equals voltage divided by resistance.
Okay. Yeah, that.
What is the resistance of a circuit in which a current of 3 amperes flows through a resistor connected to 90 volts? So this is our first little kind of number problem here, okay?
So don't be scared by numbers.
So one of the things that it helps to do is write down the numbers that you have, okay? So what's the first number we've got? It's a 3 amperes,
So where should we write that?
wherever you want.
So we'll just write it here. 3
3A.
A.
Yep, for amperes,
Oh, right.
right?
Yeah. Or
And then the other
amps.
number they gave us was what? 90 volts.
Yeah, 90 volts.
So-
would it be?
So maybe write it next to it, right here.
Okay. 90 V for volts.
Okay. And what we want is what is the resistance? So,
So that means we cover up this one.
right.
Cover up R.
So that means we have, if we cover up R, we have what left?
We have E and I.
Right. So E, if you remember, is what?
Electromagnetic force.
Right.
Or
and that is
volts.
or volts. So the volts goes here. Right? So you put a 90 here,
Uh-huh.
and that means the only place left is
Amps
right.
or amps. I mean.
So
Sorry.
90 divided by
Oh, yeah.
90 divided by 3.
Yeah. Which is 30, I think.
Yeah.
Yeah. B.
And that would be B. Good job. What is the current in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? A. 9,600 amperes. B. 200 amperes. C. 0.667 amperes. Or D. 1.5 amperes. Okay, so when they give you these problems, the best thing to do is kind of look at what you have. So they gave us 120 what?
Volts.
Okay, let's write that down.
Okay. So you write 120 volts. So they must have been getting it from a power
From the wall socket,
from
you
the
think?
wall, yeah.
Yeah. You can cross off the one we did before, so we don't get confused.
Okay.
And then the other thing they gave us was a resistance of 80 ohms.
Okay, so we'll write 80 here. And then ohms would be...
Do you know how to make it? I'll show you.
Ah, right.
See?
Yeah.
Like that.
Uh-huh.
That's the ohms.
Mhm.
Okay?
Okay.
So now, they gave us this, which is, they give us voltage. Where does that go on the diagram?
Which it is...
Actually, what they said is, what is the current? So which current, what do we want for current?
Amps. Oh, sorry, I.
Yeah, so we would put our finger on that,
Mm-hmm.
right? And then we have E divided by R, right?
Ah, okay.
So what's E,
So E is, I believe it's 120.
right? So 120 there,
Mm-hmm.
divided by
80.
80.
80
So
ohms.
120 divided by 80. So which answer would that be?
I think if I did my math correctly, it would be 1.5 volts. Oh,
1.5
sorry.
amperes.
Sorry.
Yeah. Yep. But you got it. That would be D. What is the voltage across a 2 ohm resistor if a current of 0.5 amperes flows through it? A, 1 volt. B, 0.25 volts. C, 2.5 volts. Or D, 1.5 volts. Okay, let's do the same thing.
Okay.
Let's first cross off what we just did. Okay, and now let's write down what they gave us. So 2 ohms.
Okay, so 2, and then the little weird guy. Beep.
And then they also gave us 0.5
0.5.
amperes. So A. Okay, and now what we want to know is what is the voltage?
Okay, so that would be, so voltage is electromotive force.
Yep.
I misspoke earlier. So that would be E. So
Okay.
cover that
I
one.
can cover it up for you.
Okay.
And that means that we're doing multiply or divide.
I think we're gonna do multiply because it's not going down.
Right.
It's
So
going across.
so we're gonna do what's I?
So I is. Oh wait, no. I is 1.5. Sorry.
Okay. Or 0.5, right?
0.5
Times.
times 2 ohms. So
Right.
that'd be R.
So, or you can do it 2.2 times 0.5. It's
Yeah.
the same thing.
Mhm.
Okay?
Yeah.
So,
Doesn't matter when you.
what's the answer then?
So I think it would be A, 1 volt.
Good job. What is the formula used to calculate electrical power in a DC circuit? Is it A, power equals voltage multiplied by current, B, power equals voltage divided by current, C, power equals voltage minus current, or D, power equals voltage plus current? So now we've left Ohm's law behind. We're doing
Bye-bye, Ohm's law.
because this question has power in it, right? And so if we
Yeah.
look at Ohm's law,
It has
There's-
resistance in it.
there's no
instead.
P.
Nope.
So we're going to use this one here for power.
Yummy pie.
So which one would it be then? So we're looking for power, right?
So P is power.
Right, so
obviously.
power.
And then we have our amps, or I, amperage. So what do they have for amperage?
So what are we doing here? Between here and
We're
here?
doing, I believe
Is that
we're doing
multiply or divide?
multiply.
Right, so what would the answer be?
The answer would be A. Power equals voltage multiplied by current.
Right. So in this case it's flipped, but that's okay, right? So it's voltage multiplied by current.
Yeah.
Right,
doesn't
okay.
really matter, though. It's multiplication. You do it either way.
How much power is being used in a circuit when the applied voltage is 12 volts DC and the current is 2.5 amperes? A. 4.8 watts, B. 30 watts, C. 14.5 watts, or D. 0.208 watts. Okay, so again, let's write down what we have. Okay, so they gave us 12 volts.
12 volts. So they're using car battery.
Yep. And the current is 2.5 amperes.
2.5. And then A for amps.
And then at the beginning of the question, they said how much power.
Oh, yeah. So
right?
we'd cover P.
Right, so power, right? And then that means we would do what?
12 volts times 2.5. So let's see. What would that be? That would be... I believe that would be...
What's 12 times 2?
Well, 12 times 2 is 24.
Right? And then what's another half?
Another half is... let's see. What's
Half of 12?
half of 12? So 6. So... Oh, it'd be 30.
Right.
So it would be B. 30 watts.
Good job. How many amperes are flowing in a circuit when the applied voltage is 12 volts DC and the load is 120 watts? A. 0.1 amperes, B. 10 amperes, C. 12 amperes, or D. 132 amperes. Okay, so let's write down what they gave us.
Which one are we using?
They asked us, well, let's write it down in a minute. Let's just put it here, okay?
So we'll cross off our other one.
Yep.
Because we're not using that one.
And they gave us 12 volts again.
So 12 volts. So they're still using that car battery.
Yep. And now they gave us 120 watts.
So 120. Would it be W?
Yep.
Okay.
What is watts a unit for?
Watts is the unit for... Oh, it's for power.
Right. So they gave us 12 volts, which is...
It would be E for electromotive force.
Right, so they gave us the E, and they gave us the watts, which is...
Power.
Right? And what we want is how many amperes. Right?
So how many amps.
So we want... Where are we going to put our finger?
So I believe we're going to put our finger on the I.
Right, so... Boop. We need to do... What's here for P?
It's 120 watts.
Right? Divided by...
12 volts.
So what's 120 divided by 12?
Would it be B? 10 amperes?
Good job.